So in this problem says Dr. John Paul Stapp was a U.S. Air Force officer who studied the effects of extreme acceleration on the human body. On December 10, 1954, Stapp rode a rocket sled accelerating from rest to a top speed of 282 meters per second in 5 seconds and was brought jarringly back to rest in only 1.4 seconds. Calculate his acceleration in his direction of motion and be opposite to his direction of motion. Okay, so part A, what they're asking you is when he was accelerating, what is the acceleration, and what was his acceleration when he was speeding up? Okay, so the final, again, we use this equation. Final velocity is initial velocity plus acceleration times time. Final velocity minus initial velocity, acceleration is that. Okay, so this was 0 and his final velocity was 282 meters per second, and this happened over 5 seconds. So this is equal to and 282. 0.4 meters per second squared. And again, we will express this in terms, we'll multiply this by 1 g times 9.8 meters per second squared. So what we're doing is dividing 56.4 meters per second squared divided by 9.8 meters per second squared times g. 5.76 g. So what this means is when he was being accelerated, the force on him was 5.8 times his body weight. So roughly 6 times his body weight. The seat was pushing him forward with the force equal to 6 times his body weight. And B, so when he was stopping, his velocity is in that direction and his acceleration is in this direction. So again, from this equation, V naught plus 8t. Okay, now his initial velocity is 282. Now his initial velocity is 282 meters per second. His final velocity is 0. He stops. So this is equal to 2 and plus acceleration times time, and he stopped in a time of 1.4 seconds. So acceleration is minus 282. So the negative sign, okay, we'll come to that in a second, meters per second divided by 1.4 seconds. Minus 201.4 meters per second squared. So the negative sign tells you that the acceleration is in the opposite direction of the velocity. Velocity was positive. That's initial velocity. Okay, well, let me say that's initial velocity. All right, again, expressing this in terms of g. This is 20.6 g's. Okay, so the stopping acceleration on him was 20 times his body weight, 20.6 times his body weight. So the straps that were, well, as he was slowing down, the straps, the forces on his shoulders were 20 times his body weight.